Hey everyone, in this video we are going to talk about what is Docker and how you can containerize your own application. If you are new to this channel, I am Kaiwalya Koparkar. I make content around open source, DevOps, and cloud native ecosystem. So let's get started. So what is Docker? So we can consider it as, in simpler terms, say suppose you have a box or a container. You will it as a container. So Docker is a tool which creates a space which is totally isolated and where your applications run. So what does the isolated environment mean? Isolated environment means so whatever is outside of this container, anything that is outside of this container won't be able to affect the application that is running inside, and whatever happens inside the container won't be able to affect the outside. So this is called as isolated environment. So Docker is a tool which helps you create this isolated environment, and you can run your applications inside this isolated environment. What is the benefit of this? So it's simple. So say suppose you have an application on your local system, local computer, and maybe you have it and you share that application with your friend, but now your friend is not able to run the application. Why? Say suppose you have Node.js application, but your friend does not have Node.js installed, right? So whenever they will try to run this application, the application won't run, obviously, right? But that won't happen with Docker. So where the beauty of Docker is whatever running inside the container application here, it will run exactly the same if you share with someone else. So in your friend's container as well, it will your application will run exactly the same way it's running on your computer. So it does not you don't have to bother if your friend has Node or any React library installed or anything like that. You just have to share the specifics of the container, and your friend will be able to run the application exactly as you are able to, right? So that's the basic idea of Docker. Cool. So now we know what is Docker. So let's start with how to create your Docker applications, how to Dockerize your applications. So whenever we talk about Docker, so there are three steps to create a Docker application or run your application on Docker. So first is Docker file, second is Docker image, and third is Docker container. We will see these one by one. So first we will see is Docker file. So what is Dockerfile? Let's keep it very simple. This is the file that you write. So this is the file that you write. So it has the code. What is this code and all we will see in short, but just keep in mind. So Dockerfile is the file you write, right? And this file has every single step that you want to run. Say example, let's take an example. So say suppose you want to run a React application which is on a GitHub repository, right? Or you have built a React application on your own. This is React application, right? So if you take a React application from someone or you build it on your own, what are the steps you will perform to run this application, right? So first of all, what you will do if you get a raw code, so what first you will do, you will considering you have operating system. So obviously if you are running computer, you have operating system, you have Node.js, you should be having Node.js on your computer, right? Then what you will do is you will npm I to install node modules, etc., and then you will do is npm start, right? So these are the steps that you will essentially follow to run your React application, right? So these are the steps, and these are the exact steps you will write into your Docker file, just in the Docker file syntax. So there is a specific syntax Docker file provides, and you will specify these all steps in the form of Docker file. So you will provide every single step to your Docker file, and if you miss a single step, then your application won't be able to run. So you have to keep in mind that you have to mention every single and small step in your Docker file. So it's like a recipe for your dish, right? So it's a recipe. Cool. So now we know what is Dockerfile. It's the code that you write with every steps that you want to run. Then the next is Docker image. What is Docker image? So if you are trying to install any application, what you will do is you will download its exe file. Let me change the color. Okay. You will download its exe file and you will run it, right? So for Docker to run, there should be a Docker image. So the Docker image is created when you build Docker files. So when you build the Docker file, you get a Docker image. Let me change the color again. You get a Docker image. What is this image? There are a few things you need to remember when you mention Docker image. First is Docker image is immutable. What does that mean? Say suppose you did a step wrong. Say suppose you don't want that step to wrong, or like you made changes to your website or React application, and now you want that changes to be in your image. Say suppose image is your executable file, right? So you cannot directly change your new application into the image. You will have to change it in uh, Docker file. And if the steps are exactly the same and you don't have to change the Docker file, but you will have to rebuild your Docker file to create a new image. So images, Docker images are immutable. You cannot change them once they are created. And if you have any changes in your application, you can actually rebuild your Docker file and get a new image. Then there is something called tags. Tags, you can consider it as version. So you can give your file any version like 1.2, 1.3, anything like that. And if you don't specify any tag or version to your image, it would be by default latest. So this is the default uh, tag that gets added to your image, right? And image is the one that you share. So if you want to share your application with your friend, this is the image. This is the Docker image that you share. You always share Docker image. So these are the things you need to remember when you work with Docker images. Cool. Now we have done with Docker images, and you know that it's a compiled version, maybe or built version of your Docker file. So whatever your Docker file has the steps, it will create an image. It's executable and it's immutable. Now we will see what is a Docker container, which is the next step, right? And it is last step when you are trying to build or containerize your application. So Docker container and containerizing your application, that might have made sense. So when you run the image, when you run the image, you get a Docker container. So you get a Docker container, and this is the place your application is running. So your website is running here, application, right? And this is the container that's isolated. So this is the isolated environment which we talked in the introduction. So this is the isolated container that gets created with the image, right? And now there's one more fun part, that if you have an image, then you can actually create multiple containers from it. So how many number of containers you want to make from a single image, you can make it here like this. You can create n number of containers with the same image. Cool. And in every container, it will be running your application here. So let's say suppose every application, 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 and application. And here is your application. So you can create n number of n number of containers running your application with a single image, right? Okay, so there are some things you need to remember when you are working with Docker containers, or you mentioned Docker containers. So this is the container where your applications are running. So your application is running here, right? But as we mentioned that this is a isolated environment, right? So outer world don't know what's going inside, and inner inside the container, it doesn't know what's going outside. So say suppose I have my website, like browser, web browser. Say suppose it's Chrome, Google Chrome, and this is running inside my container, right? So the outer world cannot access it, and the inner containers cannot access whatever is going outside the container. Cool. That much is clear. But now, if we are running our React application, what we prefer is when we go to localhost 3000, we should be able to see our website. That is our expectation. Whenever we build our React application, we want to see it when we go to localhost 3000, right? But if we just build our container is running, and we just go to localhost 3000, we won't be able to see the website. Why? Because again, the container is isolated environment. The localhost does not know what is container and where the application is running, but it just knows that localhost 3000 is pending and nothing is running on localhost 3000. Application is running inside the container. So now there comes a term called ports and port forwarding. So every container has its own port. You might be knowing what ports are, and if you don't, it's like an address, right? Port address where your application is running. Cool, but this is inside the container, right? The port forwarding, what port forwarding does is it. This is your computer's localhost, which not localhost, port, computer's port, which you mention here. So this is the computer's port, your local system's port, and this is a this is your computer's port, right? And this is your container's port. Now, what port forwarding does is it allows your container to communicate with the outer world. So this is kind of like a bridge. Cool. So this is port forwarding. So whenever you hit localhost 3000, it will go to 3000 port of your computer, which is this. Cool. And it will go to your port of 3000, and then it will get forwarded to your containers 3000 port, and where is the application running on your containers 3000 port. So whenever you hit host 3000 on your uh, Google Chrome, it will go to your computer's 3000 port, and then it will get forwarded to your container port, and the application is already running on 3000 container port. Cool. Again, you can experiment a bit that what if you did say suppose what if you did localhost 8 8080 8080, right? What if you did that? So in that case, what you will have to do is you will have to do port forwarding. So say suppose container port is 3000 and your computer's port is 8080 as you mentioned. So you will have to port forward it to your 8080 port. Now the bridge is made, and now what you do whenever you go to localhost 8080 on your computer, it will go to your computer's 8080 port, and then it will get forwarded to your containers 3000 port. And what is running on 3000 port? Your application. So you can access the application that's running inside the container on your local Chrome browser or any other browser in your local system. So you are able to communicate with your container through the ports. So ports are able with ports you are able to communicate with your application. Cool. So that's thing you need to know about containers. Okay, so let's see it in a demo, right? So now what we will do is we'll quickly go to oops, a repo. So this is official vMakeDev website repo. So if you want to access it, you can just go to github.com/vmakedev/vmakedevs, and this is the repo we are using. So I have just cloned the repo, and I have just run npm I to get this node folder. That's it. I have done exactly that much, right? And it already has a Docker file for you to try. So as I mentioned, Dockerfile has every single step that you want to perform in order to run the application. And you can see there are pretty much like uh, from work dir, copy, export, CMD, etc. And this might be real confusing, but let me clarify that for you. So these are the steps for to run your application inside the container, right? So the first from this from means uh, this is a mandatory field which you should have in your Docker file, and it has the name of operating system. So as I said, container is empty, and first thing you should know, want is operating system, right? So in this case, it's we are using Alpine Node version of Alpine. So it has already Node inside it because we want our application to have Node, right? So it already has Node and it's the operating system. So base operating system. Work directory, where is everything going on? So we create folders while working on projects. So this is the work directory. And for now, we are giving it home. If you want, you can give something like we make devs, uh, devs, and it will go inside, it will create a folder in your container called vmake and it will go inside the vmake folder, right? So that's how it goes. We will keep it simple for home now, and then copy, right? We are copying the application, right? So you have container, you have operating system, but you don't have anything inside it. So how will your application run? So you have application outside on your computer. Now you want to bring that code or that application inside your container. So what you will have to do, you will have to copy it into your container. Cool. So what we will do is we say that where is your application? Where is the application? So dot. So our Docker file is in like root folder for all the application folders. So this is dot. If my Docker file was somewhere else, I will have given where is my application. So it will be the path for your application. And the second dot is where in the container you want to put it. So if our working directory was dot slash we make devs, then we would have given something like we make devs or something like that, or app or anything like that. You understand the folder structure and file path of what you want to do. So where you want to copy. So we want to copy from the home, the root directory, and paste it in the root directory wherever we are working, right? So it gets copied. Expose again when we are working with containers. We want to expose a port. So every port is private by default, and it's not exposed to outer world. So you cannot just port forward and it will work magically. So you have to explicitly tell what port should be eligible for port forwarding. Cool. So you can, for this application, it's running on React and it's running on 3000 port. So we will be exposing 3000 ports. So container knows what port I can accept the port forwarding requests and how my application will be available outside the world. And then this is the command that CMD, this command runs when everything is done. So your operating system is built, your working directory is set, your everything is copied inside your container. The container port is exposed, and now you want to start the application. So what you do for React application, npm start, and the application starts, right? There are multiple things which I will tell you afterwards. So let's go ahead and build your image, right? So we have Docker file. First step, second step is Docker image, right? So let's build your image. So for that, there's commands. So first, we will run some basic Docker commands, right? So first command is, let's say you want to list all the images, what all images you have currently on your Docker. So Docker images. Cool, and it will list all the images. I have two images already on my system, but if you have just installed Docker on your computer, you might not have any image here, and it would be just this much. Only this much you might be able to see. Cool. If you want to see what are the running containers, so when we will create containers, so you will be able to see what all containers are running. So let's see Docker container ls, and it will show the running containers. So what all containers currently are running. So there is no container running right now, so it shows that. But if there are containers which are stopped, you want to see that as well. So ls minus a, so it will list all the containers, whether it's running or not running, it will just display them. Okay, so now you are able to see all the containers that were running and not, are not running right now, anything running and not running, right? Okay, so that were the basic commands for like listing and seeing what all things are there, right? So now we will go ahead and build our Docker file, right? So for building your Docker file, remember you have Docker file, first step, second step is building your image. So Docker build minus T, and I will now you have to specify the image name. So specific image name. So you can actually mention we make devs or anything you want with tag. As we mentioned, you need a tag or it will go to latest. But here I want to be specific, so 1.0. Cool. And now where is your Docker file? So your Docker file can be anywhere, right? So it's not mandatory to have your Docker file inside your folder structure, but like for good practices, we do that to make it simpler, right? So for and now we will mention where is your Docker file, the path. So currently it's in your root directory only where my terminal is running. So I will just put dot and that's done. And a good practice that I follow is I add my Docker Hub username to my image so that whenever like I have my image, I want to share it with my friend, I will just push it to Docker Hub and then my friend can pull it and run my image. So that's why this can be done afterwards, but for like simplicity of my own, I do it like I add my Docker Hub username slash the image name that I want to give to my image, the tag, and where my Docker file is, and then just hit enter and it will do some like things. We won't go in much detail like what all these steps are and what this blue and white lines and transfers, whatever is going on, we won't be seeing. We'll just be learning the commands and just the process overall, and then you can yourself dig deep into it and find out what's going inside under the hood, right? So now the image is built. Let's check if the image is built, right? So what do we run? Docker images and see if we can see the image. See, we can see the image. Here is the name for the image. Here is the tag of the image, and this is image ID and created, etc., etc. Right? I don't know why it says 20 hours ago, but it's the recent one. Cool. So now let's build a container. So we have image, second step done. Now let's go to third step, building a container. Right? Now we have an image, and as we say, we can make as many containers as we want. Here we will create one container and show how the application runs. Right? So let's go ahead and run our Docker image. So Docker run. So what are these flags? So minus IT means interactive terminal. So whatever is going inside your terminal, whatever is going inside your container, you will be able to see. So if you don't put this, everything will be working in background. So you won't be able to see the like maybe console logs or etc. When you run your React application, you get the console logs, etc. Right? So application starting development environment. So if you want to see all that and see if there is any problem, add minus IT, so you will be able to get whatever is going inside the terminal. Cool. So port forwarding, we want to port forward as we learned. So this is the first one is my computer's port. So I want to keep it 3000, and then the port which we expose. So this is the 3000 that we expose. So we will put 3000 that is exposed. And then image name. What is the image name? This is the image name. If you don't put the tags, it will search for latest one. So for this, I will put the tag. And if your image name is like incorrect or anything, or it's not on your local system, and if you run this command, it will first go to Docker Hub, search if there is an image with specific name. If it's not there, then it will search, then it will give an error, right? Cool. So let's go ahead and run this command. It will take some time. Right. So we have few updates. So the application is run and you get some errors. The website is running kind of thing. So let's test it out. We have exposed the ports, etc. So we should be able to see it on our localhost. So localhost 3000, and let's hope we are able to see. The application is now running on localhost. So this application is running inside a container, right? So, and we are able to access it in our browser, which is on our local computer outside the container through port forwarding. Cool. So this application will exactly work on my computer as it is. If I share this image with you all, we will see that how that can be done, and you can actually run this image and check it out. Check out this website. as it is. So this will run exactly as it should be running on my computer and or your computer, all the things, etc. Cool. So if we go back and just close the container, so to verify it's running inside the container, we have closed the container, we are out of the container. So uh, let's say suppose Docker container ls. So it will show the containers that are running, right? So currently no containers are running, right? Cool. There is no container right now running, and we should not be able to access it, right? So that's how our application is running inside the container. And if we just check docker container ls minus a, you should be able to see this is the container. Cool. So now you have created a container from the image, and the application is running inside the container, right? So we can reinitiate it and we can start. So when the container is closed, your application is no longer accessible, right? Now, what if we want to share it with one of our friends, as we mentioned earlier, right? So we can actually push it to Docker Hub. So when you write code, as you push it to GitHub, the same way you have to you can push it to Docker Hub, the image. Also, the Docker Hub is just a Docker registry, image registry. So you can actually put your Docker image as package on your GitHub as well. So GitHub has their own image registry, and Docker is one image registry. So we will be using Docker Hub in this case. So if you're just getting started and you just install Docker, so first you will have to create an account on Docker Hub, and then do Docker login to connect your terminal with your or CLI with the Docker Hub. My will be already authenticated, like already logged in. So it just says login successful, and then just push. So we have to put like Docker images, what all images are there, and now we have to push. We make devs one, right? So Docker push and the image name with the tag. Cool. And it will start pushing. Awesome. So now our Docker image is pushed to Docker Hub, and we can quickly check it here. So here, as you can see, last push 2 minutes ago, and if you just go ahead, so you will be able to run this image if you just run docker pull Kaiwalya Koparkar slash we make devs. If you pull this image using this command and try to run a container on it, then you will see the exact same application that was being on my local host. You can access it on your local host as well, and that's how you can share your applications images with your friends and everyone. And in coming videos, we will be seeing how you can use these images hosted uh, to run your application on Kubernetes cluster. So stay tuned for that. So a quick heads up that I have actually written a detailed blog on blogs.kaiwalyakoparkar.com slash Docker beginner to advanced. So in this, you can actually find everything I have just mentioned in this video, and you can actually go ahead. And this blog is actually a bit deep dive into networking of Docker, command cheat sheets, what is Docker Compose, what is architecture of the engine, why we need Docker, and everything like that. So you can actually go ahead and take a look into it. There are like some graphics to help you understand, and all the commands, different commands which we didn't see in this video. So you can actually go ahead and take advantage of this blog. And if you liked it, you can actually appreciate the blog, etc. And yeah, if you like the video, make sure you hit that like button. And if you want to stay tuned with all the initiatives of CNCF Nasik and all the videos related to open source, DevOps, and cloud native ecosystem, make sure you subscribe to the channel, and we will see you in the next one.